So a matrix is just a rectangular arrangement of numbers in rows and columns. The best thing that I can say to you is a matrix is like Excel spreadsheet. It has rows, has columns, has a place for every number, and it organizes them. Order refers to, I often use another word, the dimensions of the matrix. Okay, so order is like the dimension of the matrix. And I have there, it's M by N, so that X is read by M by N, where M is rows and N is columns. So I'm also going to write this down. Rows by column. So, rows by column. So if you're ever asked to name the order of a matrix, I want you to list rows by columns. Now, what is a horizontal? A row or a column? A row is horizontal, this, and a column is vertical. Okay, so if you need to draw a picture of row, horizontal, column, vertical, draw a picture. Count the rows, horizontal, count the columns. And within the rows and the columns, we have things that are, gosh, that X is hard to get, that are called entries. And so if you think about like that description that I gave at the very beginning, it's basically like a spreadsheet. It's just an entry into any cell in the spreadsheet. So it's like a cell in my matrix. It's any number in a given row and column. So we could name those entries, because they're like, what's the entry in the second row, first column? And then we all know where to look, and we all see the same number. Because we all organize the matrix the same way. Okay. So here is what some examples of what matrices will look like. They have these like rectangular arrangements, right? Different rows and different columns, just depends on what the matrix is. But then they have these brackets. And they're not parentheses, but they're like the square brackets. And you need to put those on the outside so that we see that's a matrix. And then we have separate entries. So it doesn't really matter if you put the exact same numbers as I put in mine, but I would maybe draw some pictures of matrices. And we're going to actually name the order of these matrices. So if you want it to match on your notes, you want to make sure they like look the same, whether or not you put the same number there. Remember that to ask for the order of the matrix is to ask for the dimensions, M by N, where M is rows and N is columns. So I want you to name rows by columns. There should be numbers there. Go ahead and have a chat with your pod members. Can you name the rows by columns for each of those? Okay. See what you can come up with. How many rows? in each matrix? How many columns in each matrix?
One row, 3 columns.
One row.
Oh yeah. Sorry, I was going down.
Yeah.
There's three.
Yeah. Okay, so you go rows by columns. There's one row. So one row.
Did you guys name orders? Are you writing them down? I'll call on people, okay? Write them down, because I'll call on you and see what you guys said. Have an answer. How many rows? How many columns? Does each matrix have? What's this order? Rows by column. Okay, so let's talk about that first matrix, negative 1, 0, 3. Talon, what'd you guys say for order?
1 by 3.
1 by 3. I agree. There's one horizontal row. There are 3 separate columns. Okay. Max, what'd you say for 0, 0, 0, 0?
2 by 2.
2 by 2. Jet, what'd you guys say for 3, negative 2?
2 rows and 1 column.
2 by 1. And Noah, what'd you say for the last one?
3 by 2.
3 by 2. So just a little mantra you need to keep repeating to yourself because it's new. Rows by columns. And you really got to concentrate on rows are horizontal and columns are vertical. Now, I'm just going to keep saying a couple of quick things about each of these because there are some interesting things about these particular matrices. When a matrix has one row or one column, it can be referred to as a row matrix or a column matrix. So those are special matrices. You might say, like, you might hear in a direction, write the column matrix, and then that gives you a hint that it should have a single column. So it might help you with a particular problem. The one with the zeros in it is kind of special. Number one, it's all 0 entries, right? So if your matrix has all 0 entries, it can be referred to as a 0 matrix, which, let's be honest, is not very interesting. This one is also special because the number of rows is equal to the number of columns. Anybody have a name they think could work for that? Square matrix. Yep, good. So it's a 0 matrix. It's also a square matrix. So square matrices are really important because some matrix operations, you do like a whole chapter on matrices in Algebra 3 and in pre-calculus. Some matrices, like determinants, can only be done with square matrices. 2 by 2, 3 by 3, 4 by 4, those types of things. 3 by 2 doesn't really have any special names. It's just a regular old 3 by 2 matrix. But I do want to just say that, like, a lot of times when we're learning about matrices, we're just going to see this rectangular arrangement of numbers and it means nothing to us, right? But you could imagine in a spreadsheet, in a table, where matrices might be something that's really useful for us as a way to organize our data. I could maybe say that this 3 by 2 matrix, maybe this column is boys and this column is girls. And then for my rows, they would have different labels. Maybe I have my 9th graders, my 10th graders, and my 11th graders. And then that then provides meaning to my entries, right? The entry in the second row, second column, 6, means that I have 6 10th grade girls in a class. So it's a really awesome way for us to organize data and then to perform operations with that data. So you could see why this would be super helpful. You've maybe used Excel, so you might know. Okay. I'm going to pose this question to you, and I'll just have you have a quick chat with your group. What do you think should be true in order for two matrices to be equal? What do you think has to happen? What has to be? Share with your group. What would it mean if they're equal?
Wondering which ones? The exact same.
You like the same number of
Okay, what are some ideas that groups put out there? What should be true if two matrices are going to be equal? Just throw out an idea. It's okay if it's not. Same order. Oh, I like that. So same order, and I heard some other groups being like specific there. It has the same number of rows. It has the same number of columns. Did you say anything else?
Same entries.
Same entries. The word that keeps coming up is same. So in order for two matrices to be equal, and the two matrices have to be exactly the same. They gotta be the same size, same order, and not only that, but their entries have to be the same. So I'll just do, here are two. I'm just having a little bit of fun with that, but those would be equal matrices. Do the entries look exactly the same? No, but are they exactly the same? Yes, in value. Okay, so the square root of 4 is 2, 1/2 is 0.5, so we know those things to be true. Okay? So that's a question that I ask you, and like you already know what it means to be equal. Things have to be the same. Okay, so don't think too hard about matrix equality, right? Matrix addition or subtraction. Suppose I gave you these two matrices. Do you suppose I might be able to subtract them? If I were going to subtract them, what would you do?
Would you subtract to like wherever the numbers that correspond in the same spots, like 3, -1, -2, -3?
Corresponding entries will be added or subtracted. So in order for you to be able to add or subtract, this order is order
2 by 2.
2 by 2. This order is
2 by 2.
2 by 2. And the difference will come out to a 2 by 2. So in order to add or subtract, they must be the same order. They don't have to be the same matrix to add or subtract them, but they do have to have, like Kaylee is describing, a corresponding entry that it could be added or subtracted. We don't want to have an extra row where there's nothing to do with the other matrix. So it all has to be the same. And then like Kaylee says, just pick the corresponding entries. Okay, now you would have to be careful with this one. This is 3 minus -1, which will come out to be 4. One thing that I often do with negative or subtraction is I change the signs of everything. I change it to plus, and then I change the signs of all my entries. So I might make this a plus, and then I'll do plus, 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 negative. And then that way I can just keep adding the two numbers. That way I don't have to worry about forgetting to subtract. So 3 plus 1 is 4. -2 plus 3 is 1. 5 plus 2 is 7. And 4 minus 2 is 2. We okay with where my numbers came from? If you had left it, if you didn't distribute the negative, you would have to do like 5 minus -2 is 5 plus 2 is 7. I'll just be real honest and say that after a couple of entries, people generally forget about their minus sign. So it's a good idea to distribute. Add. Abby is saying, don't do it. Don't fall into the trap. Order of this one is 2 by 1, 2 rows, 1 column. Order here, 1 by 2. I'm not going to be able to add the first row, first column entry. Well, I guess I could add first row, first column. But I couldn't add like the second row, first column entry, because there is no second row, first column entry over here. So then in this case, you just get to say, not possible. So you can't always add and subtract. You can only add and subtract when they have the same order. Okay. All right, I'm just going to let you jot this down. It's a matrix equation. So equation means it has an equal sign. It has a left side and a right side. The problem we just did when we were adding those two square matrices together, that was just an expression, subtracting two matrices. It didn't have an equal sign until we get an answer. And I'm wondering if in this matrix equation, you can solve for x and y. So if you want to check your matrices as you're copying them down, I'll read the first row. In the first matrix is 3 and x. Second row is -2, 1. In the second matrix, first row is 9, 5. Second row, 2y, 6. And then the answer on the other side of the equal sign, first row, 12, 1. Second row, 8, 7. If you just want to check to make sure you got your entries in there right, go ahead and have a chat with your pod. How do you think you're going to be able to solve for x and y? Chloe, you okay? Have you guys got x and y? Come up with some ideas. How might you be able to solve for x and y?
Here's the equation, so you need to add the two, so it'd be 2, 1 minus 2.
You guys have those?
So you just add 2. 2y equals 2.
Okay, let me have some ideas. Which group was able to find x? Luke, what did you guys get for x?
We got -3.
And how did you get that?
Well, they have to add to get to the third one, so we wrote out x plus 5 is 1.
I mean, you have a whole matrix equation, but within that matrix equation, you have those corresponding entries, right? And so I like that idea. That's very algebraic method, is to say I would take first row, second column entry, plus the first row, second column entry, x plus 5, and it would equal the first row, second column entry, equals 1, and then subtract 5 from both sides. You can get x equals -4. How many people were able to say x is -4 just by looking at it? Right, so I get that too. Like in some cases, it might be easy just to be like, oh, it has to be -4. And then if you can't figure out what it has to be just by looking at it, then go ahead and do like Luke's group and write that algebraic equation. Was a different group able to solve for y? Izzy, what did you guys get for y?
3.5.
3.5, or you could have had, if you have 3.5, that would be 7 halves.
Yeah.
Okay, tell us how you guys got that.
I did 2y plus 1 equals 8. Or am I looking at Oh, never mind.
So 2y plus -2. Yeah, so she said, am I looking at that wrong? Yeah. Right? That's okay. 2y minus 2 equals 8, so that's going to change our answer
To 5.
to 5. Good. But you had the right idea. Just probably like an eyeball thing, right? So no big deal. Okay, so you can do that as well. Right? No big deal. Okay. Last thing for today, I think, is something called scalar multiplication. Now, you have heard the word scalar before. You talked about scalars back in geometry. Do you remember anything about scalars? When did you use them? When did you see them? When did you find them? I think that the time I remember scalars being in geometry is if you had like two figures, and it would often ask you like, what's the scalar? Three, because it's like the thing you're multiplying each side by, like you're increasing the size by 3, or dilations and compressions. Maybe, I think, I'm not sure if you call them compressions in geometry. But that would be when I would think about a scalar. It's like a proportion or ratio. So in scalar multiplication, a scalar is just a real number multiplied by all entries in a matrix. Tomorrow we're going to do something different. It's called matrix multiplication, which is a little bit trickier than adding, subtracting, and scalar multiplication. Okay, so it gets its own day. But scalar multiplication is just saying, let's put this number outside the matrix and multiply all the entries by it. So if I do 3 times this matrix, my answer is going to be another 3 by 3 matrix, square matrix, same entries. It's just all the entries will be now multiplied by 3. So 3 times 0.5 is 1.5. 3 times 3 is 9. 3 times 2 is 6. 3 times -1 is -3. 3 times 1.5 is 4.5, and 3 times -0.5 is -1.5. Everything just got multiplied by 3. So you might also say talk about distribution. You're just distributing it to all the entries. Okay, any questions about anything that we've covered so far? Things that I have maybe left unsaid that are unclear? Okay, you've got some time to get started on your homework. What a nice thing to come back to, right? Confidence booster after your break. grade booster. This is gonna be good. Only thing you have to be careful of is going too fast. Now, if you take a peek at the back side of the worksheet, you'll notice there's now like word problems or application. So it's really about like read it, like understand the data, and then like figure out what the question is going to ask you to do one of the things that we have covered. Add, subtract, scalar multiply, okay, and then do what you need to do.